Imagine endless green fields swaying in the sunlight, the tall stalks standing like soldiers under the open sky. But these aren't just ordinary crops. This is sugarcane. And behind this seemingly simple plant lies a breathtaking journey powered by technology, tradition, and precision farming. In just a few moments, you'll witness the incredible transformation of sugarcane, from tiny stalks planted in the soil to sparkling white crystals sealed in bags. This is how sugar is really made, and you're about to see every step of the journey. It all begins in early spring. In sugar-producing regions like India, Brazil, and Australia, March marks the start of the sugarcane planting season. But what used to be a slow, back-breaking task has now become a highly coordinated, tech-driven operation. Farmers begin by selecting the strongest, most disease-resistant stalks. These are cut into smaller sections called sets, each around 30 centimeters long with 2 or 3 buds, just enough to sprout into a brand new plant. These sets are loaded into mechanized sugarcane planters that are capable of planting up to 20 hectares a day. Guided by GPS and real-time mapping, the machines drop each set into freshly plowed soil at the perfect depth and spacing. In older times, it took days of manual labor to cover just a few acres. Today, automated planters can cover that ground in hours, with better accuracy, less human error, and higher success rates. Manual planting is now a thing of the past. Precision agriculture ensures that every inch of land is used efficiently and every plant gets an equal chance to grow strong. Once covered with moist soil, the sets begin their slow but steady transformation into a vast, green canopy that will tower several meters high by the time it's ready to harvest. After planting, the next challenge is hydration. Sugarcane thrives on water. It needs about 1,500 to 2,500 millimeters of rainfall or irrigation per year to grow optimally. But in today's world of changing climate and shrinking water supplies, that kind of consumption can't go unmanaged. Instead of flooding fields blindly, today's farmers use smart irrigation systems. These are connected to underground soil moisture sensors, satellite weather forecasting, and real-time mobile apps. Every irrigation event is planned based on soil moisture readings, root zone data, evapotranspiration rates, and upcoming weather predictions. Drip lines or rotating sprinkler arms deliver water directly to the roots. Not a drop is wasted. In many countries, this has reduced water use by nearly half, while simultaneously increasing yields by up to 20%. Fertilizers like nitrogen and potassium are also delivered through the same lines in carefully calculated doses. What used to be guesswork is now a science. Watering crops is no longer a chore. It's a calculated operation, fine-tuned by weather models, soil analytics, and data collected from the field in real time. 10 to 12 months after planting, the lush green fields are nearly ready. But one more dramatic step is needed before the harvest: fire. This isn't an accident. It's a deliberate process called pre-harvest burning, and it's been used for centuries. Controlled fires are set across thousands of hectares. The flames race through the fields, stripping away dry leaves, deterring snakes, killing pests, and clearing out underbrush. The result? Bare, clean cane stalks. Easier for machines to process and safer for workers in the field. The smoke rising into the sky is carefully monitored. Burn windows are chosen when wind conditions are calm, humidity is just right, and fire risk is minimal. Fire breaks are created to prevent accidental spread, and entire teams are on standby to control the blaze. Why burn at all? Because clean cane is processed faster, contains less trash, and leads to higher sugar recovery rates at the factory. It's not just about tradition, it's about efficiency. Once the flames die out and the fields are cool, it's time for the machines. Modern sugarcane harvesters are giants, up to 4 meters tall, weighing over 10 tons, and powered by artificial intelligence and hydraulics. Each machine performs multiple functions at once. It cuts the stalk at the base, strips off remaining leaves, chops the cane into billets, sorts the cane from residue, and loads it into the waiting transport trucks. And it does all of this while moving, continuously, efficiently, and intelligently. Thanks to GPS and field mapping software, these harvesters follow precise cutting paths to avoid missing cane or cutting too low. If they cut too close to the ground, it can damage the root system. Too high and sugar content is lost. Precision matters. Some machines are now semi-autonomous, able to adjust cutting height based on stalk maturity, soil condition, and plant density. In top-producing nations, these machines work around the clock. In some areas, night harvesting is even more common, as it helps preserve juice quality and reduce field heat stress. Each harvester can process up to 100 tons per hour, clearing fields in record time. What once took hundreds of workers now takes just a handful of skilled machine operators. Sugarcane juice begins fermenting as soon as it's cut. That means speed is critical. Transport fleets, often managed by software platforms, coordinate thousands of truckloads every day. Each truck can carry up to 40 tons of chopped cane. As one is filled, another takes its place. The cane is rushed from field to mill, usually in under 12 hours, to preserve sugar content. Any delay means loss in juice quality, which directly affects sugar recovery. Along the route, trucks pass through weigh bridges, moisture checks, and quality inspections before entering the processing plant. The entire system is a high-speed network, one built on the clock. As trucks unload at the mill, the cane is lifted onto a conveyor belt system that feeds the preparation station. Here, powerful blades shred the cane into small fragments, increasing surface area for juice extraction. From there, it moves into crushing mills, massive steel rollers that squeeze out every drop of juice. In modern mills, this process is fully automated. Operators monitor extraction rates, pressure, and juice flow on digital dashboards. The goal is to extract as much juice as possible with minimum fiber residue. The leftover bagasse, fibrous waste from the stalk, is collected, dried, and stored. It's not trash. In fact, it's one of the most important byproducts in the system. The extracted juice isn't ready yet. It's filled with dirt, plant material, wax, and bacteria. In the clarification tanks, lime is added, and the juice is heated to 100 degrees Celsius. This causes impurities to coagulate and separate from the liquid. The clean juice flows out and moves on to the next stage, concentration. The waste solids, now called press mud, are collected and often reused as soil conditioner or organic fertilizer. The purified juice is now thickened in large multi-effect evaporators. These chambers boil off water using steam at various pressures. As the juice thickens, it becomes syrup. The syrup is then seeded with tiny sugar crystals in vacuum pans. Over hours, the syrup begins forming solid crystals, the very same sugar grains we use in our homes. Temperature, timing, and purity are tightly controlled. Even a slight deviation can cause poor crystal formation. After crystallization, the sugar is ready for separation. The sugar and molasses mixture is poured into high-speed centrifuges that spin at over 1,000 revolutions per minute. The spinning forces separate the sugar crystals from molasses. The molasses is drained off and collected, while the sugar is washed and dried using hot air systems. The result is bright white, sparkling sugar, ready to be packed. Molasses isn't wasted. It's sold to distilleries, animal feed producers, and ethanol plants. Every drop is valuable. Once dry, the sugar moves to the automated packaging station. Here it's packed into various grades, raw, refined, or specialty, and sent off for use in beverages, confectionery, pharmaceuticals, and even industrial chemicals. Some mills pack over 3,000 tons per day, with strict quality control at every step. Meanwhile, the earlier bagasse is now burning in boilers, producing steam and electricity. Many sugar mills produce more power than they consume, selling excess energy back to the grid. The ash left from combustion goes back to the fields as potash-rich fertilizer. This is a system where nothing is wasted. Everything, from leaf to stalk, juice to ash, has a purpose. From a tiny set buried beneath the soil to a stream of white crystals flowing from machines, sugar's journey is long, intense, and nothing short of extraordinary. It's a product of sun, soil, fire, water, and above all, precision. Behind each spoonful of sugar is a symphony of science, sustainability, and human effort. Next time you sweeten your tea or bite into a soft pastry, remember the story behind that sweetness. If this journey inspired you, don't forget to like this video, share it with your friends, and subscribe to Infinite Farming for more real stories from the future of agriculture.